Hello and welcome. I am going to do a walkthrough of the first round of the FMW Brazil case today, round one. It's called Troca or Troco, which I think was change of change. There's some pun on like things changing and change from cash. So I did a test solve of this one before the round, but I will say usually Klinsmann sends me something that's pretty tight, but this time I did find some bugs in it, but that meant that my test solve was mostly, me getting confused and wondering if something was wrong and blah, 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 which wasn't very exciting. So thought I would do a fresh solve because this is a fun case and it deserves something a little more exciting than that. So I'm not going to make you watch me try to struggle through translating things from Portuguese this time. Uh, so exchange change. Whenever we buy something with cash, depending on the amount we give to the seller, we need to get money back. This is called change. If you want to buy an item that costs $1.99 and you pay $2, you get 1 cent back. Different sections based on multiples. The example above is a real world case. We're calculating the difference based on an integer number without decimal places. That's not what we're going to face in Troca Troco. Here, instead of integer multiples, people from different households will buy your products and find decimal or fractional multiples that they will have to compare with and see if the difference is positive or negative based on the amount they paid. It's a little confusing, but it'll become more clear when we... Okay, so here we go. For example, if a question tells us that the multiple is 0.24, 24 cents, then we should carefully read what is being asked. If we pay 50 and the question asks us to compare the nearest number based on that multiple, then the nearest multiple is 48. So 2 times 24 cents, or 0.048, 0.48. But if we pay the same 50, but the multiple is 0.17, the nearest number would be 0.51. 0.17 times 3. And then additional instructions for cashback and family, level 6 and 7. For level 6 and 7, there will be cashback and family mechanics that will need to be taken into account. For this additional information, the data in the households tab is provided. So that's familias over here. And then from level 1 to 7, make sure to use the round function with 2 decimal places in the final answer to avoid infinitesimal errors. I think this might have gone in part based on my feedback. Use this function only in the final answer. The development of the question should not use any partial rounding. Okay, so let's go straight to the levels first. So if we pay 10 for an item, what would our change be? Okay, so we're starting off pretty light. So let's do 10 minus each of these. Hooray. Okay, what is the result of subtracting between the nearest whole number and the amount paid? Am I reading that right? No. The nearest. Oh, sorry, the next. Proximo. I'm thinking of proximate, like in English word, proximate next whole number. So here we're going to say round up this to 0 decimal places will give us the nearest whole number, which is 3. And then we're going to subtract this, and that'll give us what we're looking for. Oh, hang on 1 second. This is the one that I remember being wrong before. I don't remember this one being wrong, but unless maybe it's the rounding fun. So let's round to 2 decimal places just to be safe. Yeah. Okay, fine. So this was, let's just undo that and see what we actually had here. Okay. Sure looks a lot like it, but never mind. So we'll round. All good. Okay, level 3. Let's go back to translating. This question, calculate the result of the subtraction between the nearest multiple of 0.5 and the paid amount. Okay, so the nearest multiple to 618 is 6. Fine. So the m round function is going to be helpful here. So we're going to say, let's see, m round this to the nearest multiple of 0.5 minus this, and then for the sake of caution, we'll wrap the whole thing in round to 2 decimal places. Super. Okay, level 4. Okay, so for level 4, we've got various different multiples. What are we doing with them? Let's see. This PT, this one over here. Okay, so for level 4, we must find the largest absolute difference of the subtraction between each of the numbers closest to multiples 1, 2, and 3 and the amount paid. So closest to multiple 1 is 160, closest to multiple 2 is 168. Closest to multiple... Okay. So that gives differences of -1, 0.7. Okay, so I think what we want is m round this with this multiple, and some of these functions don't like to take a range, but you can persuade them to by saying, no, it's not a range at all. It's an array by putting a plus in front of it. Don't ask me why. Anyway, so it's those round numbers minus this gives me differences of -1, 0.7, and -17, which is exactly what we want. Then we want to take the absolute value of those. We want to take the maximum of those. And we want finally to round it to 2 decimal places just to be safe. Okay. And we're all good there. Okay, level 5. Let's go back to translating. Wait, can translate take a range? Probably. I bet every new function can. Yeah. Yes, it can. Look at that, that's cool. D. Okay. Instead of fixing the amount paid, we fix the multiple. Makes sense. Now we've just got one multiple, but 5 different amounts paid. It's following the same logic of subtracting the nearest number paid, the nearest number and the paid amounts. We must add the differences after the 5 purchases. And is it a signed difference or an absolute difference? That's negative. That's negative. So yes, so it is a signed difference. Okay, so we want m round all of these to the nearest multiple of that, and again we'll probably need yes to put a plus in front of this. Then we want to subtract these. Then let's just see. So we got negative 0.05, 0.17. Yes, that looks fine. Then we want to sum those, and then we want to round it to 2 decimal places just to be safe. Hooray. Okay. Going much more smoothly than my test solve. Okay, cashback incluso. Let's see what's going on here. Translate. Actually, I don't know why I'm putting it way over here. I can just put it right next to it. Translate this. Actually, if I did do it this way, even better. Okay. For those between the ages of 18 and 30, inclusive, they can buy things through the smartphone app, earning 15% of their money back. Amount paid must first be corrected, subtracting the 15% part, and only then apply the multiple to be compared with the nearest number. What is the average difference of the change after the cashback criteria? Do not round any partial criteria. In example 6, the first, second, and fourth names use cashback, resulting in these weird numbers after subtracting. Okay, fine. So then we're going to take the average and we're going to round it. Okay. All right, so we got some funky text stuff going on here. So we'll text split this. Let's see, it looks like we got this space dash space separating a name from a number. So that's the column delimiter, and then we've got space slash space as the row delimiter. Okay, so that gives us all of these names, all of these numbers. Are they? Oh yeah, they are. I was wondering if I had to remove the word name, but I don't. I do, actually I am going to remove the word name just for fun, because then I can index rather than looking up, and it'll be a little faster. So I need to ignore empty, and that'll work fine. Then I also, because this was written for Brazilian audiences, we've got a comma as a delimiter, so I'm going to need to replace that. So we'll say substitute comma to period, as Americans call it, and then we can multiply all of this by 1, and that is my data. So then I need to figure out ages. What was the range? 18 to 30, I think. Blah, blah, blah. Yes, 18 to 30. So yes. And wait, I'm only seeing. Oh, sorry. Yeah, these are the names, not the ages. Okay, sorry, never mind. So, all right. So let data be that. Then we'll say ages can be xlookup take data first column in. Does this have a name? It doesn't. Oh yeah, and I don't need to look it up. I can just index. Index on age by that, and let's just return ages so I can look at it. That's good. Then I want cashback can be ages greater than or equal to 17.5 times ages less than or equal to 30.5, just using round numbers to avoid any wobbles. So that gives me the first, second, and fourth, which I think is what it said here. Yes, first, second, and fourth, good. So then I want prices will be take data last column times 1 minus 15% times cashback. So in other words, if it's cashback, I take off 15%, otherwise I don't, and return prices so we can look at them. 5.96, yes, 4.794, yes, 5, okay, good. And then we want to compare these to the multiple. So I'll say deltas, that will be m round prices to the multiple of this minus prices. And then I want the average and rounded. Sorry, I thought I wanted an absolute, but I don't. So let's return, round average of deltas to 2 decimal places. Does that give me minus 0.8? Yes, hooray. Okay, so we'll paste that in. Whoops, sorry. We'll paste that in that way, good. And that passes. Okay, so now level 7. Get a little complicated for the last two, but that's okay. That is what level 7 is, 6 and 7 is supposed to be. So this one is long instructions, but that's okay too. Let's do this. Value paste so I can read it in the formula bar. Okay, be sure to pay your bills. Sure. Cashback functionality will not apply to households who have not paid their bills in the past. If the person is entitled to receive cashback but is from the listed family, the 15% cashback will not be applied. If the person was not entitled to cashback and is still from the listed family, they'll suffer a penalty and increase the initial amount paid by 25%. For level 7, find out the average. Okay, fine. So, is there something about... Oh, sorry, got it. So this is the family that has not paid their bills. Changes from each one. Okay, got it. So let me just see. Paid, not paid, cashback, no cashback. So if you've paid your bills and you get cashback, it's minus 15%. If you haven't, it's 0. If you don't get cashback but you paid your bills, it's 0. Otherwise, it's plus 25%. So it's not actually symmetrical. So I was hoping I could simplify things a little, but never mind. All right. Hopefully, we can mostly take this and carry it over, but let's see what we can do. So first things first, we're going to have to move this because this thing is much wider now. So point it to that, and point this to that. But we're not done yet, so I don't want the average. So cashback is good. Then unpaid can be minus index. What's that table called? TBFAM. Familia. Oops. So index on that by this set of rows. That's the index. It has to be equal to this family over here. Boom, boom, comma. Okay. So then, say adj is going to be if unpaid. Let's just do choose. What do I want to say here? I want to say 1 plus unpaid plus 2 times cashback. Is that too complicated? I'm going to do it. So if you're not unpaid and you're not cashback, then it's 0. Then to add 1 to that, it's your unpaid, but you're not cashback. So that's 25%. Then if you got a 0 there and a 1 there, that means you're cashback, but not unpaid. So that is this one, minus 15%. And then if you're a 1 on both, that gets you 4, which is 0. Okay. Then prices is that times 1 minus adj. And then, is that it? The average of the absolute differences. So average of absolute of deltas. So I should be getting 0.09, and I'm getting 0.08. Darn. Okay. So let's just do some checks. So I'm going to call this out and Should really have built this over more cells anyway, but never mind. So we're going to HStack. I want data, ages, cashback, unpaid, age, prices, and deltas. There are too few arguments for what now? Oh, because I'm missing a comma there. Fine. So then my data is number, price, age. What comes after age? Cashback, unpaid. Then the adjustment, price, delta. Okay, so does it give any details in the example? Name 65 deserves cashback, so the new amount paid is 5338. Yeah, come on. Oh, stupid. It said 1 minus age, but I already factored in the sign, so it should be 1 plus age. There's 5338, and let's now see what output looks like. Let's call this check, keep it there. Oops, sorry. Don't want to output nothing, I want to output output. 0.09, feel better about that. And they're good. Okay, so now let's go do bonuses. So just double check, do I have, yes, got all the basic points. So let's translate all of these from Portuguese. Won't let me do that. Oh, fine. Won't let me do that either. That's kind of annoying. Stupid merge cells. Okay, which question number from 71 to 130 had the highest multiple presented? Delete the samples. How many times from question was the integer part of the multiple equal to 1? Delete the samples. Okay, so for these I want to grab the multiples for both. Multiply all the amounts paid by 100. How many of them are greater than or equal to 800? Delete the samples. Okay. Which name appears the most in level 6 questions? Concatenate the answers from bonus 1, bonus 2, bonus 3, and bonus 4 in this order. Oh yeah, I remember this one depends on all the other. All right, fine. So, so first let's get the multiples from 71 to 130. So the multiple is not always in the same column, so I'm just going to go get it by hand. Oh, actually, sorry, 71 to 130 is in fact always in the same column. Okay, fine. So we just have to delete out the example, the labels, and that gives us 40. Wait, 110? Didn't I read to 130? Am I dreaming? I did read to 130. I guess there isn't a 130. And oh, wait, there is. Sorry. So the multiple's over here now. I was right that they changed columns at least. Okay. Talking a lot. Okay, so that's 60. So I think the first question was just the largest one. 2.24. Oh, no. The number of the question. Bah. Match that against that, and then we need to add 70. Okay, then how many times is the integer part a 1? So say sum minus minus int of this equals 1. Okay. Question 3. From questions 11 to 70, multiply all the amounts paid by 100. How many of them are greater than or equal to 800? Okay. So 11. That's 50, and then 70, I think, is the one. Oh, no. I thought it was then going into multiple columns, but it's not. Okay. So I think I can just say countifs. Was it greater than or greater than or equal to? Greater than or equal to 8 is the same as how many will be greater than 800 when you multiply them, but was it greater than or greater than or equal to? How many are greater than or equal to? Yes, so it should be that. Good. Okay, what is the number of the name that appears most often in level 6? So we can zip down here. Now, where's level 4, level 5, level 6? So first I just want to combine these all into one. So say text join. That's the delimiter that gets used. all of these. Then I want a text split. This by, let's see, by the same way I did it before, which is name, space, and by that. And then the other way by that. Ignoring blanks. Okay, fine. Put it over here. Then I want to drop a column from that. Drop the last column from that. So I just get these and now group by this rows, comma, 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 -2. So the number that appears most often is 90, and sorry, I need to minus minus, so I get actual numbers. And then I guess I can just take this and put it up here. Okay, so finally, concatenate the responses from bonuses 1, 2, 3, and 4 in this order. Divide this number by the highest answer of any of the level 7 questions. What is the whole part of it? Okay, so concat of all of these, just make sure that does, yes, that comes out in the right order, divided by the highest answer to level 7. And I want the integer part of that. Boom. Okay, I mean, obviously, it's not exactly an achievement to go fast on your second time round, but that is at least a way to do it. Definitely a pretty array formula heavy way toward the end. I suspect most people will have just gone data tables on these last two. And honestly, considering that I made a silly mistake that didn't become clear until I visually reviewed it, that might be sensible. This would have actually been a good place to use my lambdafy so that I could have built that check automatically, but I didn't do that. Anyway, that's all I got for today. Thanks for watching. See you next time.